Okay, so this video is going to be on the kinetics topic, and in particular the calculations. So to calculate the orders of the reactants, I like to use this method because I find it quite easy. So first we look for two experiments in which only one of the reactants' concentration changes. Then we think, by what scale factor did the concentration change? What about the rate? Then we use the formula concentration to the power of the order equals rate. Finally, to find the other orders, I like to just use the orders that I've already calculated plus a bit of trial and error. So, using this method, I'll go through this example here. So, let me get out my pen. So, what we first do is we look at two experiments where only one of the reactant's concentration has changed. So 1 and 2, because nitrogen monoxide has changed, whereas chlorine has stayed constant, and the rate has also changed. So then we use our calculator to figure out by what scale factors have these changed. That's part 2 on my steps. So nitrogen monoxide went up by a scale factor of 2, whereas, and apologies for that horrible 2, whereas the rate went up by a scale factor of 4. So then, using my third step, the concentration to the power of the order equals rate, well, if 2 equals 4, the order has to be a 2, because, well, I'll just write it here, 2 equals 4, the only thing that we can change is the order, so the order must be 2, because 2 squared equals 4. Okay, so once we've done that, we can figure out the other order, so the order for chlorine. Again, in this case we can just use the same method as finding the nitrogen monoxide. So this time, experiments 2 and 3, chlorine changes by 2, whereas this stays constant. So then, looking at the rate, well, this also went up by 2, and you can round, so if you get 1.997, you can round that to 2, and because that's a 2 equals 2 in my little equation style, the order obviously has to be 1, because 2 to the power of 1 equals 2, and use your calculator if you're not quite confident with these, but you will eventually pick it up. So the order for chlorine is 1. Okay, so that's how you can find the orders of the reactants. So once you've done this, I think it's quite easy then to find the value for K, and basically all you do for this is you rearrange your rate equation using known values from one experiment, and then you can kind of just do it like that. So say for instance you used experiment 1, you would just rearrange your rate equation, which is K equals rate divided by your reactants, and you would end up with your values basically, because it will just be 1.79 times 10 to the minus 7 divided by 0.125 squared times by 0.125. However, then you'll be asked to find your units for K, and to do this you can just do moles per decimeter cubed in brackets, and the power of this will be the powers in the numerator take away the powers in the denominator. So it's easy to just do this by an example below. So for the rate equation I've just said, I've already derived it here. So what we do is, the powers above, we have 1 moles per decimeter cubed in the rate, which is moles per decimeter cubed per second. Just ignore the per second for now. At the bottom we've got a power of 2 here, and obviously a power of 1 here, which we don't write, but it's there. So it'll be 1 minus 3 for the power. So then we expand moles per decimeter cubed by the power of minus 2, and what we get is moles minus 2 decimeter 6, and we just throw the s minus 1 back on. With practice you'll be able to get that, and it'll be easy, because it is easy. And that's all you need to know for the calculations for kinetics.